I'm very happy to give the first speech on this day. I hope you're all awake. I can't even see you because it's so much light in my face here. Anyway, this will also be easy, I guess, for waking up. It's not horribly technical. It's more like philosophical or even psychological, I would say. It has two of the new things, I guess, in this conference, Go and DevOps. So I thought I could connect both of them. Let's see if that works out. Let's start with my street cred. I used to work for this company called Google. You might have heard about them. You might also know that they created Go, the programming language. I worked for them for 7.5 years. And disclaimer is, I have never written Go code in production at Google. I actually have never written a real Go program while I was there, which is actually part of the story I'll tell you later in this talk. What I have learned, though, while I was at Google is I kind of peeked into the hive mind of Google. I kind of understood how they roll when they develop things, when they operate, and that will also play a role in this talk. This was my next station, SoundCloud. SoundCloud, it's everywhere. This is my current employer. I've been there for 5 years by now, so it's also quite a while. To reiterate on those words in the title, if I'm asked if SoundCloud is doing DevOps, I usually tell them, oh yeah, we're doing DevOps. We are even doing true DevOps. There's a bit of a story behind that, which is not the story in this talk, but I would say we are pretty cool DevOps company, and we are also a company that is doing microservices. I'm pretty sure that I remember correctly, the Wikipedia page for microservices had listed SoundCloud as one of the early adapters, poster childs for microservices. I checked it because I wanted to put a screenshot there on the slide. It's gone. I mean, it's Wikipedia. I could have re-edited it or something, but okay. Anyway, we were pretty early in the game when it came to microservice migration. So another word from the title. And to complete it, we were also pretty early adapters of Go. We were even considered a Go shop back then. I'm not sure if that was ever true. I would not say that nowadays SoundCloud is a Go shop. It's more a Scala shop. The reason why that has happened will also be part of this talk. But when I started at SoundCloud 5 years ago, I had a starter project. This is what we do, right? You join the company and then you help somebody else in their project to get into how the company works. And that person I worked with was Peter Bergen. If you're a Go fan, a happy gopher, then you might know Peter. He is pretty active in the community. He gives a lot of really nice talks, and he was also there early on. Back then, he was at SoundCloud, and he wrote a microservice in Go, and I joined him in that effort. So totally microservices, Go, DevOps, everything there, but yeah, nowadays we are not writing a lot of microservices in Go, and Peter's also not at SoundCloud anymore, which again will be a part of the topic of this talk. My final street cred proof is this one. It's also here on my laptop. You might know, I hope you know what that stands for. That's the Prometheus logo. Prometheus is a metrics-based monitoring and alerting system, which I have been busy with for quite some time. This is totally a DevOps tool. People always ask me, is Prometheus a DevOps tool? And then I think, I don't know what's a DevOps tool, but Prometheus totally is a DevOps tool. Prometheus is especially suited to monitor microservices. There we are, and it's written in Go. So, perfect match for the topic of this talk. But let's not just do my own stuff. Let's do science. Let's go to GitHub. GitHub thankfully tells you what language a repository is written in. And then there's a totally scientific measure of popularity, which is GitHub stars, the most important currency in the open source world. So you can search for repos that are written in Go, and you can sort it by number of GitHub stars, and then you get a list. I just picked the top 14 because they fit on 2 slides. But yeah, it's all very scientific, as you can see. The first one, the most popular repository on GitHub written in Go is Moby, which is something container. I mean, I'm not going into all the details here. We just want to find out what areas those repositories, like what areas do they cover. And if it's about containers, it's totally DevOps, right? I mean, that's a fallacy. You can do DevOps without containers, or you can do containers and totally not do DevOps. But for simplicity, let's assume Moby is a DevOps tool. Does that actually? Yeah. The second one here is the language itself. It's also hosted on GitHub, so that doesn't really count as a Go project if it's the language itself. So let's not look at that. The third one is Kubernetes. It's also here on my laptop. That's a everything changed. Oh, cool. Kubernetes. That's a container orchestration framework. You might, or hopefully you know about it. It's even more popular than Prometheus, and it's written in Go, obviously, and it's totally DevOps, right? Containers, scheduling, orchestration. Up there, Lantern. That looks Chinese to me. You might not have heard about it, and if you haven't heard about it, it's because you're living in a free country. This is a tool to circumvent the big firewall. So hopefully we will never need that. But it's written in Go, and that's kind of networking web browsing, right? So it's a bit different. The next one, Awesome Go, is just a curated list of links to other projects and libraries and frameworks in Go. So that doesn't really count, but tells you how popular it is. Hugo, that's a static site generator, which is almost front-end, right? Like it's a Go program to generate websites, static websites. So even there, it plays a role. Let's walk to the other side. What do we have here? Gox, or whatever that is. That's a Git, hosted GitHub something. So it's source control, dev tool, perhaps even DevOps. The next one is, again, this one is a ebook about writing web applications with Go. Doesn't really count as a Go program, but since there's a very popular ebook about writing web applications with Go, I guess you can write web applications with Go. SyncThing is a file synchronization tool, again, networking. Gin is an HTTP router, which is like good for writing web applications, but also good for writing microservices, should they use HTTP, which many of them do. And we're almost there. Go Ethereum, the B word. Blockchain must be everywhere. I think if you write a Go client for some blockchain thing, it doesn't tell us a lot about Go. It's just a very hot thing. etcd, that's the key value store at the basis of, it's the kind of backing key value store for Kubernetes, can also be used on its own, totally a DevOps tool. Prometheus, I think I talked about it, right? There it is again. And Caddy is an HTTP2 web server. So we see a lot of things that are clearly DevOps tools for whatever definition you use, but I think it's pretty clear. It's networking, web serving, even like front-endy things, and a bit of microservices, web apps. So kind of makes sense. This is what Go is used for. Mostly like, let's say, systems programming. We can only, GitHub stars are not so scientific at all. So let's look what the industry is doing. And a very hot and hipster industry foundation is the Cloud Native Computing Foundation. That's a sub-foundation of the Linux Foundation. And it's essentially all the cloud providers, everybody who has some say in the industry is in this foundation. It has been founded as the home of Kubernetes, essentially. So when Google also created Kubernetes, I might not have mentioned that, they wanted Kubernetes to not be a Google thing. They wanted it to be owned by some vendor-neutral entity, so they could have just handed it over to an existing foundation, or they could have founded a foundation of their own just for Kubernetes, the Kubernetes Foundation. What they actually did was something in the middle. They created a sub-foundation of the Linux Foundation, which is like not quite a new one. And they said this should not just be for Kubernetes, this should be for a set of tools that we need in the modern cloud-native world, and they called it Cloud Native Computing Foundation. They donated Kubernetes. The Cloud Native Computing Foundation is hosting many projects. They have a 3-tier entry procedure. You're either sandboxing, or you're incubating, or you're graduated. There are 2 graduated projects, and now you can probably already name them, Kubernetes and Prometheus. They are both written in Go. And now let's look at all the incubating projects. I won't go into all of them in detail, but I have to watch this here together with you. Let's check this. Containerd is written in Go. Rocket is written in Go. CNI is written in Go. Jaeger is written in Go. Even has the Gopher in its logo. Notary is written in Go. Vitess is written in Go. Coordinates is written in Go. NATS is written in Go. Helm is written in Go. Rook is written in Go. So there we are. It's almost everything written in Go. There are language projects that are not written in Go. Fluentd is Ruby. This is C++, I think. Envoy C++, and Linkerd is Scala. All the other 3 projects are not really written in any language. They are more like standards or API definitions. Like gRPC is remote procedure calls you can do in any language, right? It's not that you can say gRPC is written in Go. So of all the projects that are written in a particular language, most of them, an overwhelming majority of like CNCF projects are written in Go. Now you could say this is the leading industry foundation in the field. Everything is written in Go, almost. So we can stop here, right? Like Go is the way to go in the cloud native world, which is kind of has a huge overlap with DevOps. Done, right? We just follow the crowd. But no, you should not do that. Like you should think, you should play devil's advocate. So let's play devil's advocate. This is about distributed file storage. There was a time where people wrote distributed file storage in Java. Hadoop, right, comes to mind. I don't know why that was considered a good match. Whatever. I mean, I think Java was just super popular back then. It was the dominant language that everybody knew. And you still had a platform issue, right? You wanted to distribute those programs everywhere, and there was a platform diversity out there. Nowadays, for better or worse, that has been solved. There's essentially one platform the internet runs on, which is containers on Linux. So kind of the JVM is more like overhead. But anyway, they wrote distributed file systems in Java, but I'm not talking about Hadoop now. I'm talking about ExtremeFS. If you have never heard about it, don't blame yourself. It's an open source project, even had EU funding, was very academic, but it never really like took off as a popular network file system, distributed file system, for reasons not to be discussed here. But some of the people in the initial team who, whatever, wrote their PhD thesis about it and everything, they thought, if this is not working as an open source project, but we know it's good stuff, let's found a company and create a commercial enterprise version on top of that. That company is called Quobyte. And if you look at their job description, they're not hiring Go developers. They're hiring Java and C++ developers. So you can assume they are probably rewriting some of this in non-Java, but the language is not Go, as we might have assumed from the previous slide. The language is C++. So why? I actually asked them, and they looked at me when I asked, like, why aren't you using this hipster Go thing? And they looked at me blankly and said, how could that ever work? Like, there's garbage collection. The garbage collector kicks in at some point and stops the world. Actually, back then, this is a few years ago, Go garbage collection was really problematic. It had like multi-tens or hundreds of milliseconds stop the world garbage collection. If you are working in a like millisecond latency or sub-millisecond latency requirement, then you can't do that, right? And also the scheduler, like they looked at me and said, I cannot control the scheduler. Like Go routines are scheduled, maybe, perhaps at some point. So it's actually, you don't have a lot of control of those things you need for something like a file system. So yeah, not a perfect fit. Perhaps they could use Rust these days, which avoids the problem of garbage collection by not having garbage collection. Also avoids the benefits, of course, but yeah. Let's look at something that is actually written in Go. Docker. For some reason, it didn't make it in the top 14 most popular repositories on GitHub, but it's immensely popular, right? Docker made containers popular. Containers existed before Docker. SoundCloud was using containers before Docker. Google was using containers long before Docker. You could argue they kind of invented containers for Linux, or at least pushed the development because they needed it long ago. But like Docker made it popular. Docker's written in Go. So for managing containers, perhaps Go is the right choice. If you ever see Casey, he used to work for CoreOS, which then became Red Hat and now kind of became IBM all of a sudden. He gave this talk at one of the Go meetups in Berlin. I haven't found a recording. Perhaps he's giving the talk somewhere else and you can see it, or you find a recording. But there are slides. Later the slides will all be there available for you on the website. So you can just click on this link and at least you will get the slide deck, which will tell you a lot about this talk. This is mind-blowing. Casey explains how the Go scheduler works, how Go maps Go routines to actual OS threads, and this is all super sophisticated and super nice, as in you can use those lightweight Go routines instead of heavyweight OS threads. But unfortunately, there's Unix and POSIX and a lot of things that are important for container management, like kernel namespaces and capabilities and user IDs. They are all bound to OS threads. So if you manage all of this in your Go program, you might just manage one of the OS threads, and then next time you do something, your Go routine works on another OS thread, and it's all quite problematic. There's a log OS thread thing in the Go standard library, which has become increasingly useful with later Go releases. But to really do this, you need cgo. What is cgo? Cgo is to use like C together with Go. And Go has a collection of proverbs. You can Google Go proverbs, yet then you will find a web page where they have all those proverbs. And one of the proverbs is, cgo is not Go, which is true. Like proverbs are supposed to be true. So if you use cgo, you are actually not using Go. And so ironically, for Docker to do what Docker does, it needs C, right? So Go was perhaps not the optimal choice, I don't know. To see how crazy this is not from the Docker code base, it's from Open Containers, but it's a little Go package that allows you to do those namespace manipulation. And you can see this here. If you read the first sentence, the NSenter package registers a special init constructor that is called before the Go runtime has a chance to boot. This makes me dizzy already. And if you read on, it's like, yeah, mind-blowing. If you ever see something like this in your Go code, this is C code in your Go code, and it's run at specific locations. It's like all where you think, this language was clearly not meant to do this, what it's doing here. Yeah. Okay, third point, playing devil's advocate, memory management. There's an old bug in the Go repo, the second most popular repo in Go, which is the language itself, which asks for mechanisms for monitoring heap size. Because that's something that many programs need. Many programs need the memory they need, and if they can't get it, it's fine to crash. Like Go just panics if it's out of memory. But other programs, they want to take the memory they need, and then they want to take as much memory on top of that as possible to do a better job. Caching comes to mind. Those programs don't want to They want just to take the memory that they still have available without ooming. And that's really hard in Go. Fittingly, the one, they list many examples in this issue. It's very long. You can read it up. You can find it after the talk. There was Prometheus quoted as an example for a program that actually needs that, and I clarified this a bit. So if you want to blow your mind again, you can follow all those links where I link into the Prometheus code base to show you how Prometheus manages the memory despite using Go, and it's not pretty. It's really like weird. Now, the irony comes now. The irony is that this is Prometheus 1 code base. Prometheus 2 doesn't need that anymore because there's now a much better way of caching. We use mapping, which asks the operating system to do the caching for us. But still, there are a lot of programs who need that. And even mapping is not really a first-class citizen in Go. Like, you need to take the real raw syscall to mmap something, and then there is another Go proverb that syscalls always have to be guarded by build tags, which means you need platform-specific code. You need different code for Unix and for Windows, and perhaps even for different flavors of Unix. In the mmap case, that works rather well. Like, it's just a tiny bit of code that is platform-dependent, but you still notice Go was never meant to do those things. So why? Why are all those hipster cloud-native systems, DevOps, whatever tools using Go if it's such a bad systems language? I have ideas why they use that, but I'll come to that later. Let's first try the other thing. If Go sucks for systems programming, perhaps it works for microservices and for your actual product. There were a few repos in our scientific survey, so let's look at that. Go and microservices is definitely a thing. I just stumbled upon a 15-part blog post series by Eric Lupander about writing microservices in Go, and I mean, it will haunt you. I think I stumbled upon this because the part 15 is about monitoring your microservices with Prometheus. But anyway, this is not about Prometheus and Prometheus being written in Go. This is about the microservice you monitor being written in Go. And so there's totally a community doing that. If you just Google Go microservices, the first hit is actually GoKid. And now another circle is complete. GoKid was created by Peter Bergen, my mentor in my starting project at SoundCloud. And this was also created at about the time where Peter left SoundCloud, so there's a bit of correlation. So this is a kit to allow you to write microservices in Go in a really nice way. And it's also fairly popular. It's not one of the top 14 popular Go repos at GitHub, but it's fairly popular. So you should be able to write microservices. So now let's look at SoundCloud just for a second and think about the story of Go at SoundCloud. So SoundCloud definitely loves all those cloud-native tools. We use Kubernetes. We had a container orchestration thing before Kubernetes, homegrown. It's a bit of an adventure, but it was also written in Go. We kind of created Prometheus, which is written in Go. So yeah, we are definitely familiar with that, and we are also still using Go a lot in the infrastructure area. But we are not using it a lot for microservices. So how did that happen? When we started with microservices, we fell into that common trap of thinking, oh great, now we have microservices. That means every team can do their own thing, right? They write their own servers, so every team can pick the tool they like best, the language they like best, and we had this Cambrian Explosion, animations with Google Slides. But anyway, a Cambrian explosion of tools and languages at SoundCloud. I joked we had more languages than engineers, which was probably not true, but it was an approximation. And some people use Go, some people use Clojure, some people use Haskell, and you can come up with any hipster language you want, and we will probably have a microservice in that language. Our Sean Treadway is our principal engineer. He called that optimizing for individual productivity, which sounds good, but it's actually not good because you want to be productive as an organization. And that was not optimizing for productivity as an organization because what happens in the real life, people come and go. They leave the company, you hire new people, or you have people moving around within the company. That's a good thing. That's agile, like lowercase a, agile. And microservices are micro because they are also like easy to move around. I can say, okay, this team now owns this other microservice. And if those two people who really liked Haskell and wrote a bunch of microservices in Haskell leave the company because they want to work for a 100% Haskell company or something, then all of a sudden somebody else inherits the ownership of that microservice and they now have to learn Haskell. I mean, it's not a bad thing to learn Haskell. It's probably good to learn Haskell. But you wanted to write a new microservice or you want to fix a bug, but now first you have to learn a new language, and perhaps a language that will teach you a lot but is difficult to learn. So at some point we realized, okay, we have to converge on something, and we also realized that we need to reduce the constant cost per microservice, because that's another thing. For microservice to work, it must be easy to create a new one. And there is always a constant cost. Like everybody has to implement a circuit breaker or something. Some of this is complicated, and people have to reinvent the wheel all the time if they all use their own tooling. So you want to share a bit. Like this share nothing approach is perhaps not so good after all. So we created some framework, and we also built on top of what others did, and our choice was Finagle back then. Twitter's Finagle stack, which is written in Scala, so you're ideally writing your microservices in Scala as well. At least you're bound to the JVM. And what happened then, this was 2015, it's kind of the year of GoKid and the year Peter left, and it's all happening back then. Phil created this slide. Phil Calzado, you might know him because he talked a lot about our microservice migration. He was like leading that more or less back then. And he wrote this infamous slide internally: building in Scala should be a no-brainer. Sure, because we're using Finagle. Building in other JVM languages should be easy. That's easy because you can still use all the tooling, and like we built some stuff on top of Finagle. We called it JVM Kit, so it was very easy to create microservice. Building in something else should still be possible, right? This is kind of the liberal approach here, where you said, oh great, I can still write my microservices in Go if I really wanted to, which is still happening. Like if you have a good reason for that, and this might be performance, certain behaviors that where Go might be better than the JVM or something. This is still happening, but all the Go fans were looking at the slide and saying, okay, now we are kind of third-class citizen in this new world order. That didn't make everybody happy, but it kind of makes sense in its own way, right? Because we wanted some convergence. We just didn't converge on Go. So now some people said this was just happening because there was no Finagle for Go. Finagle was Scala/JVM. And you could say GoKid is Finagle of Go. And I mean, I don't know if it's on the web page, but Peter had a few initial talks about GoKid, where he essentially said, this was kind of a tragedy. Go lost the microservice battle at SoundCloud because there was no Finagle, so we should have Finagle for Go and create a GoKid. I mean, broadly simplified. Anyway, now everybody could just go and, no pun intended, go and create microservice in Go. It's happening. My view might be biased because I go to all the Gopher meetups, but not to the Scala meetups. So I see all the companies really using Go mostly, and not studying so much the Scala companies, except my own one. But yeah, it's totally possible to do that. Of course, SoundCloud is not going to rewrite everything Go now because we have our tooling, we have our existing microservice. It works sufficiently well. And also, a very powerful language like Scala has certain advantages. Like it's very expressive. It's kind of what I call a multi-paradigm language. Whatever programming paradigm you want, you can do it probably in Scala in a very elegant way. While Go is kind of the super primitive thing where, yeah, I don't know. I call it a no paradigm language. We will later see if this is actually a disadvantage or perhaps not. To understand why Go is the way it is, this is the psychology part now, we should go back to Go's childhood at Google. and understand the parents and the upbringing, and then we will do a bit of psychoanalysis and we'll understand why Go is the way it is. So Google had this weird idea that you should only use 3 languages. It actually makes a lot of sense, again, from a certain perspective. It's kind of the opposite of our Cambrian Explosion. They used Java, Python, and C++. C++ and Java being just industry leaders back then. Python, when Google adopted it, it was fairly exotic, but now it's also one of the dominant languages of our profession. So that also kind of makes sense, but I think they didn't pick those because they were so popular, or it played a role, but they wanted to cover certain areas and they didn't want loads of many different languages. They are adamant about it. Like if they acquire a new company, like one they totally integrate their code base into their own code base, and it's a Haskell code base and it's super ingenious code, eventually will all be rewritten in C++ or something. They of course do use other languages, like you cannot write iOS apps without Objective-C, and you use JavaScript to run in the browser, but they are all kind of special purpose, domain specific. For general purpose coding, if that's a word, they used to use those 3 languages. And then there were so many attempts of fans of a certain language to teach the Google Hive mind, to convince the Google Hive mind that this 4th language is totally required and you should adopt Haskell or Lisp or Ruby or whatever, and nobody succeeded. Google hired like the best Lisp coder in the universe, only to tell him you will never code Lisp for money again, which is really weird. But it makes sense. It's from their perspective, it's a certain model of doing it. To add insult to injury, at some point Google added a 4th language, and it was none of the languages that people wanted. It was a newly created language, Go. So this is weird, right? Why did that happen? Let's think about certain peculiar things in the Google model of developing and operating. First of all, believe it or not, Google probably has one of the largest internal code bases in the universe, and it's all in one repository. It's the monorepo. It has become, like a couple of years ago, it became a bit popular, and some companies thought about if they should do the same. But that one of the companies with the largest code base is using a monorepo might be surprising. Also, what Google did is something we now call it microservices, but they did microservices before it was called microservices. That's even cooler than before it was cool, because it didn't even have a name. Similar to the containers, right? Then some people think microservices implies also micro repos. Every microservice has its own repo. You could do it that way. SoundCloud is definitely doing that way, for better or worse, but you don't have to do it that way. Google has this monorepo approach. That has a lot of implications. For one, you need a very strict style guideline for your one repo. So every single one of those 3 or now 4 languages is really strictly regulated. You kind of have to acquire a driver's license to even check in code and stuff. Like, it's quite authoritarian. Plus, you also restrict those languages. C++ is almost like Scala, multi-paradigm language. And at Google, you essentially get told you might have learned C++, but forget 90% of it. This is the way we are doing C++. Python is perhaps better fit to the Google development model, but still they ban, for example, or especially power features. Like if you want to use meta classes because it's cool, they will tell you, no, it's banned in our code base. So they have a kind of special, they made all those languages DSLs for their use case. Then they have libraries, very powerful, common libraries in all those languages, which is one of the reasons for having a limited set of languages, so you have the same kind of libraries for all of them. For one, to enable you to use the company's infrastructure, like Google File System, MapReduce, whatever. And also, again, to essentially have one way of doing things, and it's done in that way throughout the whole company. The C++ library has been open sourced recently. I mean, the parts that are generally applicable, it's called Upsile. it's kind of German, it was in Zurich or whatever, upsile.io. It's pretty cool to look at that, and you can learn a lot about how like Google works. Then, perhaps again surprising, builds are static, which in C++ is straightforward, right? They statically link everything in. Every binary is humongous, but that solves the dependency problem. Java, Python, they don't really do it that way, but like spiritually, it's done in the same way. Like you have gigantic Python archives that have bundled all dependencies. The idea is you have one giant blob you deploy somewhere and it works. This, for some people, appears weird, like it's backwards. We have 20 years of progress with shared libraries, and now Google comes along and says, no, shared libraries was a mistake from the beginning. Ironically, people are doing something very similar everywhere now. They just call it containers. Containers bundle all the dependencies, and it's a giant blob, and you put it somewhere. So Google didn't need containers for that. They had solved it by their static builds, but they needed containers a lot for other things, like resource isolation. So another irony, like the reason why we have containers on Linux is not the reason for why we all use containers now. But anyway, there's also very strong unified tooling for like quote-unquote modern debugging, diagnosis. So it's all via HTTP endpoints. You can easily profile a binary over the network. You can do a thread dump. You can have metrics. You can have distributed tracing. And it's all unified everywhere there and available in all those languages. So now, let's look at Go and check all those points against it. Everything makes sense now. If you use Go, especially in the early versions, you might have been surprised that there is no dependency management whatsoever. Why is there no dependency management? Because it comes from a universe where there are no dependencies. There's one repository. Dependencies, what do you mean? Link in something from somewhere else? There's no somewhere else. There's only the one repo, right? That's why we have no real dependency management built into Go from the beginning. Then there is this Go FMT, GoFimt, which formats the source code for you in the one and only way source code must be formatted. There's very strong and powerful and strict GoVet and GoLint, and this is all coming from Google's authoritarian regime about coding style. It's now built into the language. Static binaries. Go could not dynamically link everything in the beginning. It could not create shared libraries, and people thought, what, backwards, Stone Age? But no, this is the way, the light that Google has seen and the way to do it from the perspective of Google. Fast compile times, everybody was amazed how fast Go compiles, but the reason was that if you have a gigantic monorepo and if anything changes and every second you have multiple changes and you have to recompile everything because you always build from head because that's super agile, then you want super fast compile times. What else? The tooling. People were, like traditional programmers, were disappointed that there's no step-by-step debugger for Go from the beginning. But all the people who had like done distributed programming and concurrent programming, they were super happy with the tooling because it had built-in profiling, everything like XVAR, all those things that are there, like Go routine dumps that are super nice. This is all coming from the tooling how Google works, and it makes a lot of sense. A step-by-step debugger in a concurrent and distributed program doesn't make so much sense. So again, now you can understand all the good parts and the perhaps surprising or bad parts in Go. It's all coming from its childhood. Of course, why should Google create a new language if they have already tailored all the other languages to that model? Again, I have ideas about that. As an exercise, you could think which languages Go is actually replacing. I mean, it's not replacing anything totally, but you can now, of course, I mean, if we had an internal view of Google, we could see what programs that are now written in Go at Google would have been written in C++ or Python or Java before, and then you can get an idea where it was most dearly needed. That might lead to some surprises, but it's a bit of speculation. So let's do something else. Let's think about the one thing that is unique here in Go, and that is its concurrency model. which is CSP. Communicating sequential processes. That's a paradigm how to do concurrent programming. It's not a very new thing. It's an older paper. This is again a link. You can click on it if you get the slides on the website and read about it. It's a very lightweight abstraction, but it makes a lot of sense and makes like modern concurrent programming really nice. And of course, you can implement this in all languages. Just that in C++ you can do everything, of course, but it's not built in, right? Java, the JVM is pretty well suited for concurrent programming, but the original Java concurrency model is just totally not CSP. And of course, nowadays most people use Java in a different way, or they use one of the other JVM languages. Python. And also like things like Ruby, they just like you can do concurrent programming, but the runtime is just not suited for that. That was also a reason why SoundCloud couldn't like just keep Ruby running. Concurrent programming there is like on the machine level, it's really problematic. Anyway, Go had this built in. This is CSP is built into the language primitives. It's the first language that has that, so I called Go a no paradigm language. Now I might correct myself. It has one paradigm, which is CSP. Or you could say concurrent programming is so important in modern programming languages, it's not even a paradigm anymore, it's a required feature. A modern programming language needs a sane concurrency pattern built in, and then it's not a paradigm, and Go is again a no paradigm language. You might have heard another of those Go proverbs, which is the famous one, don't communicate by sharing memory, share memory by communicating. That's essentially CSP, broadly simplified. It's really in the soul, heart and soul of the language. Okay, but there's still one feature I haven't mentioned, which I think is the most important feature. Slide goes dark, because now I have to tell you a story, personal story, my SoundCloud story, how I came to SoundCloud. I quit Google for reasons that are also not topics in this talk, but I took my time, I investigated which company I could work for, and at some point I decided to at least apply at SoundCloud, and then they sent you a little homework. They sent you a coding challenge, and I decided, okay, let's solve that coding challenge, but I could do that in Python, I guess. I'm pretty familiar with that. But I could also make use of the time and learn a new language. For example, Go. It's a shame that I worked for Google and never used Go. So I sat down on Friday evening, opened golang.org, took the Go tour, and then started to code a bit. And I mean, yeah, Sunday evening I submitted my solution to that challenge, and a week later I had a job. I mean, they also did interviews and stuff, but I literally, and when I say literally, I mean literally, I literally learned Go and wrote a productive program in one weekend. And that's, I think, is the most important feature of Go, and the most important feature in the modern, agile, dynamic world. You have to be able to learn a language very quickly, especially in large teams, in large companies where people move around and they have to share code a lot, and there is a price. I mentioned how powerful Scala is, and Go is sometimes, it's so horribly primitive that you could cry, but you get something back. You get back that you can learn it very quickly, and you will only have like 5 or 6 surprise moments in your whole career, and not 5,000 like in C++. This is so important. In the larger organization the more dynamic it gets, you want this, right? You also want this convergence on a specific coding style, and it's amazing. People join a team programming Go. They've never done Go before, and within weeks you are all on the same page in the way you code. This is great. And now the important insight why all those C and CF projects are written in Go. I think the important insight here that an open source project works in that regard quite similar to a large company. Even worse in a way. In a large company, all those people, they depend on one boss, and this boss might tell them, because the boss pays the money. You have to write code in this and that way. You have to tame voluntary workers in an open source project, and you have even more people, and they don't even sit in the same room. They don't even know each other. They don't see each other, and you still have to converge on a certain coding style. All of that is super easy with Go, and that's why I think it's a very good choice for a large, popular open source project, even if it might not be technically the best choice. All right, final thing. Go is good for microservices. I guess with the tooling we have now, you can totally do that. If a company approaches me and tells me we are doing microservices mostly in Go, could you imagine working for us? I would say, of course I could. I would even like that. Go for DevOps. Clearly, it's not a systems language in the classical sense. You should know the limits. But that's also good. Go is explicit and deliberate about its limit. I like this a lot. I got really initially I was totally intrigued by all those languages that solve all your problems. I had Scala on the top of my list of languages to learn because you can do everything. You can do all paradigms. Isn't that cool? And then I realized that's very cool for a small team or for your coding in your living room, but it's not a good thing for large teams. And you actually, it comes at a price. Given all of that, given that it's explicit about its limit and you have to take them into account, it's also a great language for DevOps. At some points, we cursed our choice when doing Prometheus, but the bottom line is it was a good choice, and perhaps the project wouldn't be where it is now if we had not chosen Go. Also, all those languages I did, and I started with Fortran 77, was pretty low. Go is the most addictive language. I don't know. I think perhaps this whole simplicity and being really strict about things and principle of least surprise, it gives me some kind of peace of mind when I code. It's Zen or something. But anyway, I like it, and I think we have 3 minutes for question. Thank you. All right, how does that work now? I can ask you a question if you don't have one. Just raise your hand if you use Go, productively. Okay, quite a few. All of them. Which is you can just shout it out. It often works. What is your personal problem with Go? What do you think is the biggest problem? Okay, great. Another one? Error handling. Okay, cool. I already mentioned dependency management, that it doesn't exist. I have bonus slides here. Because this is next talk. I hope Christoph will like the teaser. Because these are the first 2 things in its abstract. Now they're here. Lack of generics and vendoring, right? Of course, error handling, but I think it's the 3rd biggest problem. And it will be addressed in Go 2. Lack of generics is really fascinating. This is, the code vendoring, we understand now why there's no dependency management. It makes sense. And it's kind of almost solved now with Go modules, but we understand why it was a problem. Generics is interesting because Google always wanted generics, even in their internal thing. It's just so hard to get it right with this idea of keeping everything simple and principle of least surprise. And there were 4 attempts of putting generics into Go. They were all rejected, and now they have a 5th one for Go 2, and it looked promising, but now I followed the discussion, and I don't think it will work that way. It's really a hard thing to get generics with the Go philosophy of simplicity and least surprise. But it always works. Everybody thinks the same. They're this is the biggest problem. Okay, anything else? Are you inspired to ask a question now? If not, should we close the session here?
Okay, thank you very much, Björn. Let's give a big applause to Björn. Thank you.
Thank you.